everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equation. So let's get going. Problem: solve d power 4 plus 3d square minus 4 into y equals to cos square x minus cos hx. Firstly, let's find order and degree of the given differential equation. Identify the highest derivative. Here d power 4 is the highest derivative, so our order will be 4, and the highest power of the highest derivative is our degree. Degree is 1. Or just write the given differential equation as d power 4y plus 3d square y minus 4y equals to cos square x minus cos hx. We know that d is a differential operator. Then d square will be, and d cube will be, and d power 4 will be d power 4 by d x power 4, right? Now let's replace, or let's write d power 4y as d power 4y by dx power 4 plus 3 into d square y by dx square minus 4y equals to cos square x minus cos hx. Here the highest derivative is d power 4 by d power 4y by dx power 4, right? So our order will be 4, and the highest power of the highest derivative is our degree. Degree is 1, right? Now coming to the problem. Given differential equation, d power 4 plus 3d square minus 4 into y equals to cos square x minus cos hx, which is in operator form. F of d into y equals to q, where f of d equals to d power 4 plus 3d square minus 4, and q equals to cos square x minus cos hx. Now we need to find the general solution to the given equation, which is given by y equals to yc plus yp. We will find yc using the roots of the auxiliary equation of the homogeneous equation of the given non-homogeneous equation. Simply by taking RHS to 0, we will get the homogeneous equation f of d into y equals to 0, which is a homogeneous equation of the given non-homogeneous equation, and we will find yp using 1 by f of d into q. So firstly, let's find yc using the auxiliary equation of homogeneous equation of the given non-homogeneous equation. The auxiliary equation of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, we have f of d power 4 plus 3d square minus 4, right? Let's replace differential operator by m so that we'll get f of m equals to m power 4 plus 3m square minus 4. Then our auxiliary equation becomes m power 4 plus 3m square minus 4 equals to 0. Now let's use synthetic division to find roots of this equation. Let's write the equations of m's. Constant quotient of m power 0, and quotient of m square is 3. Quotient of m power 4 is 1, right? Quotient of m cube and m is 0. Now just take the polynomial and let's see which m satisfies the polynomial. Firstly, let's try for 1. 1 power 4 plus 3 into 1 square minus 4 is 1 plus 3 minus 4, which is 4 minus 4 equals to 0, right? So m equals to 1 satisfies this polynomial. So let's take m equals to 1 firstly. Okay, for 1. 1 plus 0, 1. 1 ones are 1. 0 plus 1, 1. 1 ones are 1. 3 plus 1, 4. 1 fours are 4. 0 plus 4, 4. 1 fours are 4. Minus 4 plus 4 is 0. Again, from this, we'll get another polynomial. Right? M cube plus m square plus 4m plus 4. Now let's see which m satisfies the polynomial. Here we are having all plus, right? So 1 is not possible. If you replace m by 1, you won't get 0. Four plus 4, 8. 8 plus 2, 10. Right? It's not 0. So 1 is not possible. Likewise, 2, 3, 4, all positive numbers are not possible. No positive number can satisfy the polynomial. So let's try for m equals to minus 1. Minus 1 whole cube is minus 1, plus minus 1 whole square is 1, plus into minus minus, 4 into 1, 4, plus 4. Minus 4 plus 4 gets cancelled, minus 1 plus 1 gets cancelled, equals to 0. So m equals to minus 1 satisfies this polynomial. Now let's take for minus 1. 1 plus 0, 1. Minus 1 into 1, minus 1. 1 plus minus 1 is 0. Minus 1 into 0, 0. 4 plus 0, 4. Minus 1 into 4 is minus 4. Plus 4 minus 4 is 0. Okay. From these three numbers, we'll get another polynomial, right? M power 0, m power 1, m square. So we'll get m square plus 4 equals to 0. Right? Now, see from m equals to 1, m equals to minus 1. From m equals to 1, we'll get m minus 1 equals to 0. M minus 1 will be one factor. And from m equals to minus 1, we'll get m plus 1 equals to 0. And from these three numbers, we'll get m square plus 4. Right? One factor, I can say. Now we can write polynomial as product of m minus 1 into m plus 1 into m square plus 4. Then this equation becomes m minus 1 into m plus 1 into m square plus 4 equals to 0. Right? Now equate each factor to 0. From m minus 1 equals to 0, we'll get m equals to 1. From m plus 1 equals to 0, we'll get m equals to minus 1. From m square plus 4 equals to 0, we'll get m square equals to minus 4. Then m equals to plus or minus square root of minus 4, which is equals to plus or minus. You can write minus 4 as minus 1 into 4. Again, you can split square root of minus 1 into 4 as square root of minus 1 into square root of 4. We know that square root of minus 1 is I and square root of 4 is 2. So we can write this as plus or minus, replace square root of minus 1 by I and square root of 4 by 2. So we'll get plus or minus 2I. Right? Or you can write this plus 4 as minus of minus 4 equals to 0 is equals to, here you're having minus 4, right? You can split this as minus 1 into 4. We know that I square equals to minus 1 and 2 square equals to 4. So replace minus 1 by I square and 4 by 2 square, then we'll get m square minus of, replace minus 1 by I square and 4 by 2 square, then we'll get m square minus, you can write I square 2 square as 2i whole square, right? This of a square minus b square form, so you can write it as a plus b into a minus b. Now, equate each factor to 0. M plus 2i equals to 0. M minus 2i equals to 0. From m plus 2i equals to 0, you'll get m equals to 2i minus 2i, I mean. And from m minus 2i equals to 0, you'll get m equals to plus 2i. So then, m equals to minus 2i and plus 2i, which is nothing but plus or minus 2i. Right? So we got roots m equals to 1 from m minus 1 equals to 0, and m equals to minus 1 from m plus 1 to 0, and m equals to plus or minus 2i from m square plus 4 equals to 0. We got 1, 2 plus 2, 4 roots. We know that if two roots are real and distinct, then we can write yc as c1, one constant into e power 1 root into x, plus the other constant into e power the other root into x, right? And we know that a plus ib is a complex number and its conjugate will be a minus ib, right? If a minus ib is a complex number, then its conjugate will be a plus ib. So we can call a plus or minus ib as a pair of complex conjugates, right? If you have a pair of complex conjugate roots, then our yc will be e power ax into one constant cos bx plus the other constant into sine bx. See, already I have used c1 and c2, so I took c3 and c4 here. Okay. Now let's write for plus or minus ib. In case of a0, we'll get e power 0 into x into c3 cos bx plus c4 sin bx, which is e power 0 into c3 cos bx plus c4 sin bx, right? Which is nothing but when m is equals to plus or minus ib, we'll get yc, which is 1 into, since e power 0 is 1, right? Then we can write this as e power 0, 1 into c3 cos bx plus c4 sin bx, which is nothing but c3 cos bx plus c4 sin bx. Right, now let's write complementary function. So therefore, m equals to 1 minus 1 plus or minus 2i are the roots of our auxiliary equation, which are real and distinct and complex conjugate and complex conjugate. Which is nothing but two real and distinct roots and a pair a pair of complex conjugate roots. Right? Now let's write complementary function to our problem. Complementary function. Y is equals to, firstly let's write for these two real and distinct roots. C1, take M1 as 1 or 1 as M1 plus another constant into e power another real and distinct root. Okay, plus now for plus or minus 2i. C3 cos 2x plus C4 sin 2x. Then YC becomes C1 e power 1 into x is x plus C2 e power minus 1 into x is minus x plus C3 cos 2x plus C4 sin 2x. Now let's find particular integral. See, without using synthetic division method, we can also find by factorizing the polynomial. Okay, you can write m power 4 as m square whole square plus write 3m square as 4m square minus m square minus 4 equals to 0. Then take m square common from the first two terms, you'll get m square times m square plus 4. And now take minus common from the next two terms, you'll get minus of m square plus 4 equals to 0. If you notice, you're having m square plus 4 in both the terms. So let's take m square plus 4, common from these two terms. Then we'll get m square plus 4 into m square minus 1 equals to 0. Now equate each factor to 0. From m square minus 1 equals to 0, you'll get, you can write this 1 as 1 square, right? You'll get m square minus 1 square equals to 0, which is of a square minus b square form. You can write it as a plus b into a minus b equals to 0. Now equate each factor to 0. M plus 1 equals to 0 and m minus 1 equals to 0. From m plus 1 equals to 0, you'll get m equals to minus 1. And from m minus 1 equals to 0, you'll get m equals to 1, right? Then you'll get m equals to minus 1 and plus 1. Now, we know we already got roots from m square plus 4 equals to 0. Again, we can do here m square equals to, m equals to plus or minus square root of minus 4, which is equals to plus or minus square root of, you can write minus 4 as minus 1 into 4, which is equals to plus or minus square root of, split square root of minus 1 into 4 as minus 1, square root of minus 1 into square root of 4. We know that square root of minus 1 equals to I and square root of 4 is 2. Then we can write this as plus or minus I into 2 or plus or minus 2i. Okay, you'll get the same roots, minus 1, 1, plus or minus 2i. Then we'll get roots from m square plus 4 equals to 0, we'll get plus or minus 2i. And from m square minus 1 equals to 0, we'll get minus 1 plus 1. Then our yc will be c1 cos 2x plus c2 sin 2x plus c3 e power minus x plus c4 e power x. Right? Now let's see particular integral. can find particular integral using 1 by f of d into q. We have f of d, d power 4 plus 3d square minus 4 into q, cos square x minus cos hx. We know that cos 2 theta equals to 2 cos square theta minus 1. Now, bring this minus 1 to LHS, we'll get 1 plus cos 2 theta equals to 2 cos square theta. Now, bring this 2 to LHS, we'll get 1 by 2 into 1 plus cos 2 theta equals to cos square theta, right? So, from this we'll get cos square x equals to 1 by 2 into 1 plus cos 2x. Likewise, we know that cos hx equals to e power x plus e power minus x by 2. We can write it as 1 by 2 into e power x plus e power minus x. Now, let's replace cos square x and cos hx in yp. We'll get 1 by d power 4 plus 3d square minus 4 into, replace cos square x by 1 by 2 into 1 plus cos 2x minus, replace cos hx by 1 by 2 into e power x plus e power minus x. Right? Now, let's take 1 by 2 common from these two terms. Then we'll get 1 by d power 4 plus 3d square minus 4 into 1 by 2 into 1 plus cos 2x minus of e power x plus e power minus x. Right? Again, you can write it as 1 by 2 constant into 1 by d power 4 plus 3d square minus 4 into 1 plus cos 2x minus e power x minus into plus minus e power minus x. Again, we can write it as 1 by 2 into 1 by f of d into 1 plus 1 by f of d into second term cos 2x minus 1 by f of d into e power x minus 1 by f of d power 4 plus 3d square minus 4 into e power minus x. Right? Now, in the first term, if you notice, you're having 1 by f of d into 1 constant. So, you can write this constant as e power 0x. Now, we can write yp as 1 by 2 into 1 by f of d power 4 plus 3d square minus 4 into, let's write 1 as e power 0x plus 1 by f of d power 4 plus 3d square minus 4 into cos 2x minus 1 by f of d power 4 plus 3d square minus 4 into e power x minus 1 by f of d power 4 plus 3d square minus 4 into e power minus x. Now, I will name the first term as yp1 and second term as yp2 and third term as yp3 and last term as yp4, so that it will be convenient to find each term separately. So let's find yp1 firstly. 1 by f of d into e power 0x. So this is of 1 by f of d into e power ax form. We have f of d power 4 plus 3d square minus 4. Now let's find f of a. For a equals to 0, we need to find f of 0, which is equals to, replace just d by 0, then you get 0 over 4 plus 3 into 0 square minus 4 equals to 0 plus 0 minus 4, which is equals to minus 4, which is not equals to 0. Always remember that the denominator must be non-zero, right? Since f of 0 is non-zero, so what we can do? We can just replace d by 0, right? Then we'll get 1 by 0 power 4 plus 3 into 0 square minus 4. I'll just write the same steps into e power 0x, which is equals to 1 by 0 plus 0 minus 4 into e power 0x, which is equals to 1 by minus 4 into e power 0x is e power 0. Again, you can write e power 0 as 1, right? Since e power 0 equals to 1, then we'll get, you can write 1 by minus 4 as minus 1 by 4 into 1, which is equals to minus 1 by 4. Therefore, yp1 equals to minus 1 by 4. Now let's find yp2. We have yp2 1 by f of d into cos 2x, which is of 1 by f of d into cos ax form. Right? Now we need to find d square, which is given by minus a square. For a equals to 2, you'll get minus 2 square equals to minus 4. So the value of d square is minus 4. So now, let's see what happens if we replace d square by minus 4 in the denominator. Okay, I'll just take the denominator part. Always remember that the denominator must be non-zero. What happens if the denominator becomes 0? We'll get like this, right? We know that 1 by 0 is undefined, so the total term becomes undefined, right? Fine. Now, write d square, d power 4 as d square into d square plus 3d square minus 4. Now replace d square by minus 4, we'll get minus 4 into minus 4 plus 3 into minus 4 minus 4, which is equals to minus into minus plus, 4 4s are 16, plus into minus minus, 3 4s are 12, minus 4 equals to 16, minus 12 minus 4 is minus 16, which is equals to 0. Since it is 0, so we can replace d square by minus 4. So what we have to do? We have to write 1x into 1 by, find the derivative of f of d. If f of d is d power 4 plus 3d square minus 4, then f dash of d will be 4d cube plus 3 2s are 6d minus derivative of constant is 0. That is 4d cube plus 6d, right? Now write the derivative of f of d. The denominator will get 4d cube plus 6d into cos 2x, right? Again, you can write this d cube as d square into d. Okay. Now, again d square appears in the denominator. So what we have to do? We have to replace d square by minus 4 and see what happens. The denominator must be non-zero. Okay. Let's take denominator part and replace d square by minus 4. We'll get minus 4 4s are 16d plus 6d, which is equals to minus 10d. Non-zero. Since it is non-zero, so we can dare to replace d square by minus 4. Replace d square by minus 4. Then our yp2 becomes x into 1 by 4 into, replace d square by minus 4 into d plus 6d into cos 2x, right? This becomes x into 1 by 4 into minus 4 is minus 16 into d plus 6d into cos 2x, which is equals to x into 1 by minus 16d plus 6d is minus 10d into cos 2x. Again, you can write it as x into 1 by minus 10 into 1 by d into cos 2x. Now we can write this as x into, write 1 by minus 10 as minus 1 by 10 into 1 by d cos 2x. We know that d is a differential operator, then 1 by d is integral operator. We'll get x into 1 by 10 is minus x by 10 into, find the integral of cos 2x here, equals to minus x by 10 into, integral cos 2x is sine 2x by 2, which is equals to minus x sine 2x by 10 to 20. So this is a yp2. Therefore, yp2 equals to minus x sine 2x by 20. Now let's find yp3. 1 by d power 4 plus 3d square minus 4 into e power x. This is of 1 by f of d into e power x form, e power ax form, right? We have f of d power 4 plus 3d square minus 4. Now let's find f of a. For a equals to 1, replace d by 1, then you'll get f of 1 equals to 1 power 4 plus 3 into 1 square minus 4 equals to 1 plus 3 minus 4 equals to 4 minus 4 equals to 0. Since it is 0, we can't replace d by 1, right? If you replace d by 1 or d by a for a equals to 1, you will get something like this. And we know that 1 by 0 is undefined, so the total term becomes undefined. So here we won't replace d by 1 or for d equals to a equals to 1. What we can do? Just write 1x into 1 by, if f of d equals to d power 4 plus 3d square minus 4, find f dash of d. F dash of d is 4d cube plus 3 2s are 6d minus derivative of constant is 0, which is equals to 4d cube plus 6d, right? Here we are writing f dash of d into e power x. Now let's see what happens if we replace d by a. For a equals to 1, we'll get f dash of 1 equals to 4 into 1 cube plus 6 into 1, which is equals to 4 plus 6 equals to 10, non-zero, right? Since f dash of 1 is non-zero, right? Here we need to write, since f of 1 is 0. Fine. Now here, what we can do, since f dash of 1 is non-zero, so we can replace d by a for a equals to 1. 4 into 1 cube plus 6 into 1 into e power x equals to x into 1 by 4 into 1, 4 plus 6 into e power x, which is equals to x e power x by 4 plus 6, 10. Therefore, yp3 equals to x e power x by 10. Now let's find yp4. We have yp4, which is of 1 by 14 to e power ax form for a equals to minus 1. We have f of d equals to d power 4 plus 3d square minus 4. Now let's find f of minus 1, or simply f of a for a equals to minus 1. We'll get f of minus 1 equals to minus 1 power 4 plus 3 into minus 1 square minus 4 equals to 1 plus into, okay, plus 3 into minus 1 whole square is 1 minus 4, which is equals to 1 plus 3 minus 4 is 1 plus 3, 4 minus 4 equals to 0. So if we replace d by minus 1, we'll get something like this, right? which is undefined. Since 1 by 0 is undefined, so the total term becomes undefined. So what we have to do? We need to find f dash of d. Okay, since f of minus 1 is 0, so we'll find f dash of d here. F dash of d equals to, if we have f of d equals to d power 4 plus 3d square minus 4, then f dash of d will be 4d cube plus 3 to the 6d minus derivative of constant is 0. Now let's find f dash of a. That is for f dash of, for a equals to minus 1, equals to 4 into minus 1 whole cube plus 6 into minus 1 gives 4 into minus 1 whole cube is minus 1 plus into minus 6 into 1 6, which is equals to 4 into minus 1 is minus 4 minus 6, which is minus 10, right? Non-zero. Since f dash of minus 1 is non-zero, so we can replace. Okay, now here let's write f dash of d, 4d cube plus 6d into e power minus x. Since f dash of minus 1 is non-zero, so we can replace d by minus 1 here. Then we'll get 1 by 4 into minus 1 whole cube plus 6 into minus 1 into e power minus x, which becomes x into 1 by 4 into minus 1 whole cube is minus 1 plus 6 into minus 1 is minus 6 into e power minus x, which is equals to x into 1 by 4 into minus 1 minus 4 plus into minus 6 e power minus x, which is equals to x into 1 by minus 10 into e power minus x. You can just write it as x into, write 1 by minus 10 as minus 1 by 10 into e power minus x, which is equals to minus x e power minus x by 10, right? Therefore, yp4 equals to minus x e power minus x by 10, right? Now coming to yp. Now replace yp1, yp2, yp3 and yp4. This becomes 1 by 2 into yp1 we have minus 1 by 4 and yp2 minus x sine 2x by 20 minus yp3 minus x e power x by 10 minus yp4 minus x e power minus x by 10, right? Is equals to 1 by 2 into minus 1 by 4 minus x sine 2x by 20 minus x e power x by 10 minus to minus plus x e power minus x by 10. So, from the last two terms, let's take minus x by 10 common. We'll get 1 by 2 into minus 1 by 4 minus x sine 2x by 20 minus, take x minus x by 10 common from these two terms. Then we'll get minus x by 10 into e power x minus e power minus x. Now, take the LCM of 4 and 20. 2 2s are 4, 2 10s are 20, 2 1s are 2 5s are 2 2s are 4, 4 5s are 20. Now, the first two terms becomes, take the LCM of 4 and 20 is 20, 2 2s are 4, 4 5 is 20. So in the first term, in the denominator first term, you are having 4, 2 2s are 4. So you may need to multiply 5 to this minus 1, then you'll get minus 1 into 5, right? In the second term, you have 20 in the denominator, 2 2s are 4, 4 5 is 20. So you don't need anything to multiply to this x sine 2x, then just write minus x sine 2x is equals to minus 5 minus x sine 2x by 20. Now take minus common from the numerator, you will get minus of 5 plus x sine 2x by 20, or just take minus common from the beginning itself. At the beginning itself you can take minus common, then you will get minus of 1 by 4 plus x sine 2x by 20. Now it will be easy, right? LCM of 420 is 20. In the numerator of first term, you'll get 5 or 5 into 1 plus x sine 2x, which is equals to minus of 5 plus x sine 2x by 20. Now our YP becomes 1 by 2 into, from the first two terms you got minus of 5 plus x sine 2x by 20 into, sorry, not into, minus x into e power x minus e power minus x by 10. Now take minus common from these two terms. Let's take it out. We'll get minus 1 by 2 into 5 plus x sine 2x by 20 plus x into e power x minus e power minus x by 10. Right? Now find the LCM of 20 and 10. LCM of 20 and 10. 2 tens are 20, 2 fives are 10, 2 fives are 10, 5, 5 ones are 5 ones are, 2 twos are 4, 4 fives are 20. So 20 is the LCM. Then this becomes minus 1 by 2 into, take the LCM 20. The denominator of the first term you're having 20, right? So you need nothing to multiply the numerator, just write 5 plus x sine 2x. Now coming to the second term, in the denominator of the second term you're having 10, 2 fives are 10, so you need to multiply 2 to this term, so you'll get 2x into e power x minus e power minus x, right? Then our YP becomes minus 1 by 2 into 5 plus x sine 2x plus 2x into e power x minus e power minus x by 20. Now we can split this fraction as numerator into 1 by 2. 1 by 2 into 1 by 2 into, sorry, this is 20, right? We got 20 here, so you'll get 20 into 5 plus x sine 2x plus 2x into e power x minus e power minus x is equals to minus 1 by 2 into 20 is 40 into 5 plus x sine 2x plus 2x into e power x minus e power minus x. Now we can write the general solution. So this is required yp. Now let's write the general solution. The general solution is given by y equals to yc plus yp, right? Then our general solution will be y equals to yc c1 e power x plus c2 e power minus x plus c3 cos 2x plus c4 sin 2x plus yp minus 1 by 40 into 5 plus x sin 2x plus 2x into e power x minus e power minus x. This completes the solution. So we have seen a problem from higher order linear differential equation in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.